All kind of crazy things was happening. When at Jubilee Hospital, I mean, the amount of women that would come in with spontaneous abortions. Spontaneous abortions was, you couldn't believe it, right? A lot of babies were just spontaneously aborted, okay?
Mr. Gardner, how old
Just
is
relax.
this?
Just spontaneously aborted, right? But that can be for many different reasons, okay? One even spontaneously aborted and came out holding on to the IUD. The lady was actually holding on to the IUD. Isn't that good? So you got so I was then very hot into that kind of research work. And there, I think that was what you call a foreign body reaction of the uterus to want to expel. So the baby developing with the presence of the IUD was not compatible. You see, Crystal? So the baby actually came out with the IUD. And then there are a number of cases of microcephaly, right? And this baby here was born and the mother didn't want it. Okay? So the mother didn't want it. Okay? So in those days it would be called a monster. Right? A monster. Okay, so if you look zoom in on it, so I remember her calling me, right, and saying, Mike, the baby this lady has anencephaly. Okay, so if you look around on this side here, you see that all of this part of the head right here coming up is just like an anemone, like a jellyfish. So the forebrain has failed to develop. Okay, so you're going to see a number of these cases of anencephaly. Sometimes the congenital abnormality is so terrible that sometimes the ONG person tries not even to show the mother. Yeah, but the mother may believe that it's some kind of, bad spell on her or bad omen that she should deliver a baby like this. But this is a classic case here of an anencephaly. So she cleared it with the mother. Mother said she didn't want it. Cleared it with the head of the Department of Obstetrics and Gynecology. At that time, that was my very good friend, Professor Hall. Okay, Joe Hall, right? And everything was okay for me too. And she wrote a little letter that she is fine with what? Handing the little baby over, okay? So this is a classic case of anencephaly. Okay, then at that time now also, in another bottle was a microcephalus. So another little baby was born with a tiny, tiny little head, microcephaly. And that microcephaly, was very common in what? In when they had, what is it, chickpea or chikungunya or one of those things, or Zika, which was it part of it? No man, recently it was either Zika or the chikungunya. Zika. And in Brazil, a lot of babies were born with microcephaly. So those anencephalic ones usually, by the time they deliver, they die. Okay? Or there's just stillbirth, because all that is real there is the little brain stem. I was the head of anatomy for nearly about 20 years, so I got a lot of calls. And I remember a call now from a lady at Andrews Memorial Hospital, and she had delivered an anencephaly. A beautiful baby boy. And she called and wanted to, in fact, the Jackson Memorial Hospital wanted to harvest the heart, right? To take the heart up to this to Miami, and in the end, no, they did so. But the baby was expected to die quite, so they would have to act fast. So the little baby boy, blue-eyed little baby boy, little fella like that, survived from 8 that morning to 12 o'clock in the night. So at 12 o'clock, the little baby died. The little baby boy is right in the back there. So at 12 in the night, the hospital called. And I had to go and collect the baby. They said, we have nowhere to put the baby. You are to come and collect the baby now. So at 12 in the night, I had to drive down to Andrews Memorial Hospital and collect this little baby and collect it in a little box. And Patrick, when I carried the baby was still warm. Yeah, so it was very sad. And then I had to take the body, the little baby, up to anatomy. And at midnight and all that, I had to start perfusing the baby. Right, I worked on it till about 1 o'clock, 2 o'clock in the morning. Right? So it's right at in the back there, on the top of the tanker. Good size baby. So that was an anencephaly that survived for quite a long time. Okay, so that's quite a story. But spontaneous abortions are very common. And we get a lot of donations of various babies. Okay, so a number of people come and donate their little babies that are born. So we can zoom down on this now. So here we're looking at stillbirth. The baby of a stillbirth, right? So the brain at this level, so you can zoom in harder in. Yeah, but we can even go further down and we can look in utero. So see how the baby is looking in utero. So in utero, we'll see the first thing to develop is the sylvian fissure. You can see that. So you can fill up the screen with it. Right. So we're going to get now a lot of this folding occurring. So what are we? Which Sulci gyri are we seeing? So we're seeing the sylvian fissure. And we're seeing buried down in here the what? The insula. Do you see the insula? Yes or no?
I cannot
So you have to look, you have to zoom in hard on it. But that's the insula here. That's the sylvian fissure that's right there. And we can see that the temporal lobe, the parietal lobe, and the frontal lobe are all covering the insula right here. And we're seeing now the development of the what? The central sulcus. Right? So basically cells are moving out from around the primitive ventricle and moving towards the cortex. Right? And we're going to be getting a lot of development of the cortex, and then we're going to start to get the folding. Okay, so at the end we're only seeing about 1/3 of the actual cortex. About 2/3 of it is all hidden down in the various sulci. Okay, so there we can see the central sulcus, and there we can see this is really what is referred to as the posterior ramus of the lateral sulcus. Okay, so this is the posterior ramus, and there is at the sylvian point. So there is a baby when it's born, and we know that it has the same number of neurons as basically the adult, which Prof. Gardner would have told you, Professor Labutin, JP, would have told you is about 86 billion neurons. Okay? So right at birth, it was once 100 billion, and then they started to research and do a lot of questioning. So it's really 86 billion neurons. Those 86 billion neurons will continue. Oh my God.
I can't talk right now.
I'm in a class.
Cliffy, I'm in a class.
Poor Cliffy.
He's powering off the phone.
Yeah,
Cliffy.
so with the
In the water.
yes. Yes, so there are about 86 billion neurons, okay? Very interesting. Listen carefully now. At birth, it's about 25, the brain is about 25% of its adult size. Okay? By 1 year old, it has gone from 25% to how much percent at the end of the first year? 60%. Right? And at the end of the second year, it's about 75%. About at the third year, it's about 80%.
Oh, I read this somewhere.
So the brain has a massive growth spurt, right? Obviously, of the track systems, you know, the arcuate fasciculus of the various, all of the white matters, etc., is really forming a lot. So that first year of birth, it's nearly doubling, it's more than nearly doubling in size. Okay, second year, third year, fifth year. So the brain is developing very, very rapidly. So what does that tell you? It's for you potential mothers, right? That very important are the first few years of life.
Right.
Right. So those first two, Dr. Ledenkwe, every Saturday he's gone to visit his grandchildren. Yeah. They're Jackson and Giselle. And Jackson is maybe just about 2 years old. He's 2 years old yet, Patrick? And Jackson is so with it. Okay? Paul, greetings, Paul. So Jackson is so with it. Right? And Giselle. So I am astounded with what Jackson is doing and Giselle is doing. Alright? So the mom from birth. So early stimulation of the child. Okay? So remember that about 1 year old, 2 years old, 3 years old, the brain is going so rapidly and is setting down pathways. And also we want the right pathways to be set down. Okay? So you don't want to be shouting at a child or being too authoritative with the child. You want the child to be growing, to be able to express itself. So early stimulation is very, very important. So just to sort of leave a child in a kind of a playpen with a sucker in his thing and all of that, and then
they need colors.
when we grew up, well, we didn't come up too bad. Up to when I was coming up, you'd sit in the living room and visitors would come and see you, and children were to be seen and not heard. So you just had to, well, the visitors were there, just quiet. We said, no, Jack is not like that. Jack is expressing himself and all that sort of stuff, right? And the learning of languages. So that center, that area around Broca's motor speech area, Wernicke's area and all of that, that area is flourishing, right? So by about the age of 7 years old, right, we want to be kind of in that early period learning languages. So very interesting that at birth, we have the same amount of neurons, at 86 billion neurons, as in the adult. Okay? Now, as you know, the female brain, just for interest sake, is a little smaller than the male brain. Now, the average male brain is about 1375 grams. Okay? The average female brain is about 1,200 grams. Okay? But size doesn't mean anything.
Right.
Right? Size doesn't mean anything. Okay? The Neanderthal skull is larger, the cranial capacity is larger than our skull. And what we've found out is that cranial volume is decreasing with time. Cranial volume is decreasing with time. When you look at an animal that lives in the wild, and a domesticated animal, the wild animal has a larger cranial volume. Okay, so what we're finding basically is that size doesn't mean anything. Why is the female brain superior to the male brain?
Exactly.
Why is the female brain superior to the male brain?
It has more white matter.
More white matter.
Yeah.
Right. And more white matter means what? Paul, just put that over on that table for me. Please. Many thanks.
Joel, why do you like this?
Yeah. Paul, you look smile this morning, Paul. Paul looks so serious. Usually smiling. So the female brain has more white matter. Okay? Quite a bit more white matter than the male brain. And what does that mean with the female brain? There is more connectivity. Right? So you all have your things here, and you're looking for something called connectivity. So the female connectome is much more well developed than the male connectome. And us males know it. Okay? So the males have, when men get married, the wife really can give them a hard time, you know. Because the wife is telling them, do this, do that. JP's a married man, he knows. Lennox is a married man, he knows. Patrick is so serious. Patrick is free. Is free and single and ready to mingle. So, with the female brain now the females like to what? Multitask, because they're far more connected. There are more pathways that are working, okay? With the male, our connectivity is not like the female. So we like to just do one thing at a time. Okay, males like to do one thing at a time. Okay, so my wife is telling me do this, do that, do that. I said, look man, you've already
It all
told me.
makes sense.
And we like to just do one thing at a time. Okay, so we can multitask very well.
Exactly.
Very interesting. When AIDS just came out, right at the hospital. Yeah. When AIDS came out, listen carefully of the female. There was one male student who got stuck with a needle. I remember that student. One male student got stuck with a needle. You know when they're putting back in the AR, the accidental emergency, and they're putting the needle back in? And when that guy was stuck, man, the whole microbiology department came alive and everybody thought the poor guy was going to die. Right? No. It happened to a number of female students. Right? Why do you think it happened to a number of female students? Anonymous. They were multitasking. Oh, the boy hasn't called me today. I haven't heard from him. And he have another girlfriend and this and that. And they're thinking about all sorts of things while they're putting the needle in the what? In the little thing. So a lot of female students got stuck with the needle, right? Because they are what? They are what they're doing now, multitasking. Okay? Now, very interesting. Let's get into it. So, just get into it by showing you first of all. Okay? Alright, so this brain, I was thinking, is there a student called Alex Cox in this class? Yes or no?
No, he don't come class.
He don't come class.
Alex Cox don't come to class?
No, sit down, right?
Well,
He be there sometimes.
when Alex Cox's father was a student, Lincoln,
So,
he helped me with this brain. So that tells you that I've had this brain for about 30 years. Okay? So this is the brain that my professor gave me with no corpus callosum.
Why don't have it?
No corpus callosum there.
Why don't have it?
See? So this is agenesis of the corpus callosum. Very interesting. So I did MRIs on this brain because remember the corpus callosum occupies quite a part of the brain. So if you extract the corpus callosum now out of the brain, what would the radiology of the brain look like minus a corpus callosum? So we did this thing here, but there you can see, even I'm looking on the medial surface. What do you see different with the medial surface? We're having fun, you know. What do you see different with the medial surface? The singular gyrus is all they're broken up into parts. See that there? There's no continuous singular gyrus there at all. Okay, there is no continuous singular gyrus. The anterior commissure is quite well developed. And I told you in primitive animals, there is no corpus callosum, and the brain is just connected primarily by the anterior commissure, right? That anterior commissure is going to be will continue in us to serve us what function? What function is the anterior commissure serving in us? There are about 1.2 million axons in the anterior commissure. What function does it serve? What function does the anterior commissure serve? When we look over on the superior lateral surface of the brain, of this brain without the corpus callosum, I would say that it looks what? Rather normal. Okay, so that one is looking rather normal. And I look at this guy here, I'm just glancing on him like that. I would say he looks rather what? Normal. Okay? Where really is quite a bit different is the what? The medial surface. Right? So the medial surface is quite different as we can see. Okay, that medial surface is quite different. Right. Especially when you look right here. That medial surface is quite different. Okay, you can see that the singular gyrus. But you didn't tell me the function of the anterior commissure. What's the function of the anterior commissure?
Make Paul answer it since he was
Just give him a
late.
chance.
Since he was late.
Yeah, I'm giving you a chance. So Paul, what is the function of that anterior commercial?
It allows communication.
What is it connecting?
Hemispheres.
Receptor.
What is it connecting? Very important.
Receptor zone. No.
Connects primarily the temporal lobes.
Or temporal lobes.
Connection between the temporal lobes. It fans out and it forms an important connection between the temporal lobes, right? Also, it's like a little bus and it will collect the medial olfactory striae, right? And take the medial olfactory striae from one olfactory bulb over to the contralateral olfactory bulb. Okay? All right. Now, I wanted to be here yesterday, but I couldn't be here yesterday. And I know Jason did a very good job, you know,
He did.
on the the cerebral surfaces and all that. And I'm sure that he also showed you a section of the insula.
Yes, yes, yes.
Right, but I just wanted to show you the one that I dissected. So there is a lot of research coming out on the insula. So just listen to me carefully. So you find a lot of people with a lot of problems, like problems of anxiety, tachycardia, irritable bowel syndrome,
That kind of sounds like me.
and a lot of different things. And the root cause is at the level of the insula.
Oh?
Okay? So the insula, just relax. There you can see, this is the central sulcus of the insula. And that central sulcus of the insula is directly in line with the central sulcus or the Rolandic sulcus. Right? And that Rolandic sulcus or the central sulcus is going to divide the agranular neocortex from the granular neocortex, right? The layer 4 is not very pronounced in the agranular cortex, but in the granular cortex, it is very pronounced, okay? So an identical thing happens at the central sulcus. So that insula of Ryle, which was discovered by a man by the name of Johann Ryle, and I think the year was 1796 or 1797. I think it was 1796. He was a professor of anatomy at the University of Berlin. Okay, and he was the first one to describe the insula of Ryle. And that insula of Ryle is circumscribed by what is referred to as a circular sulcus. So in the depths of the operculum. So when we pull apart, okay, so when we pull apart, these are what are called the lips of the operculum. And if we look on the superior border, listen carefully, if we look on the superior border of the superior temporal gyrus, we're going to find 3 gyri. The anterior transverse gyrus, the middle transverse gyrus, and the posterior transverse gyrus. So we're going to be going into Brodmann areas 41, 42, and then posterior to that, this area here, all along here, that area is referred to as the planum temporale. Okay, that's involved with understanding what you're hearing. That convolution here, this U-shaped convolution, as you know, you'd have heard from yesterday, is Heschel's gyrus. So this is the inferior lip, that's the superior lip of the operculum, and this point right here is referred to as a Sylvian point. Okay, that's a Sylvian point. And if we now remove the lips of the operculum, you will then be able now to visualize the insula of Ryle. Okay? And the insula of Ryle starts at that point, which is roughly about corresponding to the Sylvian point or the pterion. That point right there is referred to as a very important point known as the Lyman insula. And Lyman means what? Threshold or entrance. So you're gone right at the threshold or the entrance of there. And as we can see, we divide up now the insula through by the central sulcus into 3 short gyri and 2 long gyri. So you find an anterior short gyrus, an anterior short gyrus, an anterior short gyrus, a middle short gyrus, and a posterior short gyrus. Now that area of the insula is involved with emotional limbic functions. Okay? So it's very limbic, the emotional limbic area. So therefore it's going to have rich connections with the amygdala, yes. It's going to have rich connections with the cingulate gyrus, and it also has connections with the hippocampus. Okay, so this area is an integrating center. As I said, when you go to the central sulcus and go posterior, you'll find the anterior long gyrus and the posterior long gyrus. This is granular cortex, so layer 4 is very thick. Okay, and where do you think the afferents are coming from for that area of the insula? And that's coming directly from VPM and VPL. So VPM and VPL are sending direct projections. So some of the planes that are leaving are landing on the postcentral gyrus, but some of these now are ending on the what? On the postcentral gyrus, on these gyri here. So from VPM and from VPL. So pain, temperature, those things, pain and temperature, very important. And gustatory function is very much associated with here. Okay, so this is the level here. This is what is referred to as, look at the terminology, the cortical recipient. What's that word? The cortical recipient of especially gustatory sense. Okay? And also the gustatory sense, etc. And remember that VPM is getting from where? The trigeminal, right? It's getting trigeminal thalamic fibers, and it's also getting what else? Very important, solitary thalamic. So your taste, solitary thalamic fibers. On VPM, the cortical recipient will be not only Brodmann area 43, the subcentral area, but right here on this part here. Okay? This portion of the arm, this anterior part that is limbic and emotion, is very, very much associated with things like empathy, emotional pain, anger, fear. All of these kind of things are associated with this. And in patients, it's also associated with problems when they're thinning out of this area, that the patients sometimes are depressed and sometimes they are schizophrenic. Okay, so that area here, and this area also, listen carefully, receives basically the same input as the prefrontal cortex. So the prefrontal cortex is working with the anterior part of the insula, because both of them have rich reciprocal connections with the dorsomedial nucleus of the thalamus. So the dorsomedial nucleus of the thalamus, which is involved with the subjective states. So this now, and I don't want to get too complicated with you, but there's an integration system across the insula in what is called a posterior-anterior integrating system. So what is coming to the posterior part of the insula is now relayed to the anterior part of the insula. And it's very much involved with the subjective states of the individual. So it's going to integrate somatosensory input with viscerosensory input. Okay, so that is going into this anterior part of the insula here. So rich connections. Now obviously, if all of this here is going to have a profound effect on what? On the autonomic nervous system. So I don't want to go into all the afferents and efferents, but it will now have a regulatory effect on the autonomic centers in the hypothalamus. So a very interesting thing to remember is RS. The right insula is regulating sympathetic activities, and the left insula is affecting parasympathetic activities. Remember that, RS. Okay, the right insula. So therefore, people like with irritable bowel syndrome, with tachycardia, and all of these things, where the parasympathetic system is becoming too much. Okay, so they've found out a lot. So there's a vast amount of research that is coming out on the insula, right? But just to say, very interestingly, that this here has direct connections with VPM and VPL, not just the postcentral gyrus, right? And this boy here has rich connections with the everything that's limbic, which is primarily the amygdala and the hippocampus and the cingulate gyrus, right? But also connections with the dorsomedial nucleus, okay? So things like anxiety, panic attacks, all of that is there. So the insula, and I was going to print a picture for you. And that is, Lennox, of the blood supply to the insula. The insula has the richest blood supply you could ever imagine. It is just how do you say, a plethora of blood vessels over the insula. So the insula is, and very interesting how it is protected. So it's protected, but it's like a little cerebrum, okay, with a central sulcus, with a granular and an agranular cortex. So the granular is posterior. So layer 4, and layer 4 is going to be producing primarily the what? The what? Layer 4 is going to be mainly from the thalamus. Okay? So we're going to do some sections of the brain. Yeah?
Something that we said this morning also.
Oh,
during the
geez.
lecture.
Yeah.
What else do you have? You will have like your arcuate nucleus, which is connecting what and what? Your Broca's area and your Wernicke area is also passing close beneath your insula. Yeah?
Right.
So if you have like a lesion in between, you can have some global aphasia. Yeah?
Right.
You have a lesion in this area. And second thing, it's also involved in your vestibular process. Okay? And also at some point, auditory process.
Right, auditory and language. Language, right. So remember that the anterior insula, this is what is involved with now, you know. Empathy. Very interesting, you know. So the anterior insula. So I have one or two friends in life. There's a friend who I am, she's female, she's not a male. And I've been very kind to her over the years. But I found out one thing about her. She has zero. None. And I'm convinced up to today that her insula is very poorly developed. Okay? So, yeah, serious. And I see that even with her family.
Is she a neurosurgeon?
Okay, very, very little empathy. Okay, very next to none. I say, oh, you don't miss so and so. No, I don't miss the person.
Wow.
She went with a guy for about 10 years. And yeah, they went with the guy for about 10 years. And the guy dropped her and she said, like, to hell with it. New Wave never talks about it. Whereas I have another friend of mine, she went with the guy for 2-3 years, and this is about 10 years ago, she can't stop talking about it. Yeah, I'm fed up of hearing about this guy. Okay, everything she's talking about this guy. Okay? So, the anterior insula, remember, very interesting, are the connections with the thalamus. Okay? And that dorsomedial nucleus, and the dorsomedial nucleus of the thalamus receives from all other thalamic nuclei. It is the integrating, viscerosensory integrating. So for your subjective states, how you feel about yourself, okay? And as I said, it does all its business now with the anterior insula, okay, the short gyrus. So empathy, the feeling, you know, that I know you're going through a bad time, your mother died or something, and I have a feeling for you. God forbid, you have a feeling, you know, and you want to empathy. Empathy, pain, right? Grief, right? All of those kind of things, and believe it or not, disgust. Right.
Makes sense.
So those patients, you know, when they're in those areas, there's some kind of disgusting things, and addiction. Okay, the whole thing. But very, very important for empathy. Okay, so you'll find that some people, all of us, our brains are developed in different degrees. Okay, let us look down here. So we want to do now our sections through the brain. That is what we're all about today. So we have to do some diagrams. Okay, relax. Okay, so we need a couple of diagrams to guide us. So what artery you think is supplying the insula? Paul, what artery is supplying the insula? What's the main arterial blood supply to the insula? Middle cerebral artery. Isn't that so? But the middle cerebral artery gives about 9 or so branches, and all of these branches are over the insula, and then we'll proceed on. So we need a basic diagram, and this basic diagram will take us through a horizontal section. All right. So there's a horizontal section right here through the cerebrum. Okay, so just watch me. Watch me, watch me, watch me. Zoom, this must fill up the whole thing. Patrick, tell me if the thing is looking good, you know. You have to peel it in, does it look good, yes or no? Yeah. So that's the genu.
Wait.
So that's the genu. No, don't get it right. That's the genu. And there we can see what are we looking at here? Internal capsule. So that's the internal capsule right here. That's the anterior limb, watch me. And that's the posterior, students, just pay attention. That's the anterior limb, relax, and that's the posterior limb.
I see.
Okay, just relax. We see here that's the anterior horn of the lateral ventricle. So this is the head of the caudate. Okay, that's the anterior limb of the internal capsule. That's the genu. That's the posterior limb of the internal capsule. So the man who lives out here is the what? The lentiform nucleus. Okay, I will bring you a better section there. This is the lentiform nucleus. And that lentiform nucleus will have an inner part known as the globus pallidus, an outer part which is known as the putamen. Relax. Then there will be the external capsule and a bit of grey matter right out here, and that grey matter out here is known as the what? The claustrum. And outside of the claustrum there's another thin layer which is referred to as the what? The extreme capsule. And there we are seeing the insula gyri. Right? We're seeing the insula gyri. So right here now I think we're looking maybe at the anterior long gyrus. This is the anterior long gyrus here. And these here will be the short gyri. And that boy is very much so the central sulcus. So you can see the central sulcus. These are the short gyri, and this is the long gyrus. So Michael Gardner is very fascinated at the amount of research that is coming out on the insula. It is so much, and you know, people who are, their lives are ruined by irritable bowel syndrome and anxiety. I've had medical students I've taught that they've graduated and they can't practice medicine, you know, Paul.
Why
because
is that?
they can't. They are struck down with anxiety. Yeah, and
So
the
like
anxiety cripples them, right? So watch out, you know, these are some very bright students I've taught. But then all of that is what, you know, with time they will grow out of it. Okay? These young people, when they have problems, not to worry, you will grow out of it.
Are you sure?
Give it a year or two, you grow. So there you can see now, that's the anterior part, that's the central sulcus. So there we see this internal capsule with projection fibers, and golly gosh, who do you think is just going right through like this? Boom! He's like a disruptor. They say Donald Trump is a disruptor. So here's another disruptor. Who do you think that disruptor is going right through this and he's disrupting the whole thing going right across? Who is this disruptor going right across? He's going right across like that. No, brother. Not at all. But it's at various levels you're going to see that's the anterior commissure. Go.
Sure again.
Right, so that's right there, that's the anterior commissure right there. And the anterior commissure has an anterior limb, etc. It's a very complex structure, the anterior commissure. Okay, connecting our temporal lobes. Relax. So there we can see the head of the caudate nucleus. There you see the lentiform nucleus, globus pallidus, putamen, external capsule, claustrum, extreme capsule, the insula of Ryle. Then we are going to see now the posterior, that's the genu, all right? And then we see the posterior limb of the internal capsule, and that posterior limb of the internal capsule comes backward, and how many parts are there to the posterior limb of the internal capsule?
3.
3, what are the 3?
Good question.
Main. Oh, the lens.
So they're all named in relation to the lentiform nucleus. So Crystal, where is Crystal? Oh, very good. Crystal says she wants us to swap cards. She saw my card today. Mr. Gardner, can you swap cards?
What car is it, Crystal?
Well, you go down the basement, you'll see my car. It's a racing car. You saw my racing car this morning, right? You saw? Very good, very good. Look at the basement and you see a blue car, that's my racing car. So there we see this is relation to the what? The lentiform nucleus. Okay? So this is the lenticulothalamic part. And the lenticulothalamic part contains what? What's in the lenticulothalamic part? Sorry, what is in the lenticulothalamic part? Corticospinal or the pyramidal tract. Okay, that's in the lenticulothalamic part. It has other fibers, ascending fibers and other descending fibers. Give me another descending tract that's in the lenticulothalamic part. Those are cortico-rubral fibers. Okay? Then in the genu, who lives in the genu? Corticobulbar. Who else lives in the genu? Also coming from VA and VL.
Good question.
Okay? And there we see now the anterior limb of the internal capsule. The anterior limb of the internal, so by the way, the posterior limb of the internal capsule, we said has 3 parts. And the 3 parts are what we said? They are 3 parts. See the internal capsule here again? So that's the lenticular. This is a big thalamus here. Right? And you can see right here that the posterior limb is very big. Okay, that's the lenticulothalamic part. And then now the next part is this part that comes right around. And who is that part? The retrolentiform part. And that's going to carry the optic radiation or the geniculocalcarine tract. Those are the ascending pathways. It will also carry descending pathways. Okay? Very important that will go into the lateral 1/5 of the internal capsule. Okay, so that's the retrolentiform part. Okay, and that retrolentiform part, then the third part is known as what? Sublentiform. And the sublentiform part carries what in it? The auditory radiation, which is arising from where? MGB. And ending where? And ending on Brodmann area 41 and 42. Okay, Brodmann area 41 and 42. So very important with that. Okay, so we saw what the actual section looks like. So let's make a drawing of it. Okay. Central to the diagram must be the what? The internal capsule. Isn't that so? Central to it must be the internal capsule. Okay, let's draw the other internal capsule here. I don't want to wet up my marker. Okay. Then we're going to find the what? The head of the caudate nucleus is here. Watch me now. That's the head of the caudate nucleus. Okay? Then now we are going to find here the thalamus. That's the thalamus, which will be right here. Over here will be the lentiform nucleus. Okay, Bogo. Which has a medial part known as the globus pallidus. Okay, and an outer part known as the putamen. Outside of this boy is the what? The external capsule. Yes or no?
Yes.
Yes. Then we find who? The claustrum. Wow, we went here soon about the claustrum. Right? Right? The claustrum. Right. Then out here, who do we find?
Extreme.
The extreme capsule. Then outside of the extreme capsule, who do we find? The insula. Reasonable? Now remember that anteriorly and inferiorly, the putamen is going to be continuous with the what? With the head of the caudate nucleus. Anteriorly and inferiorly there. And this caudate nucleus has different parts to it. What are the different parts of the caudate nucleus? What's the different parts of the caudate nucleus?
The head and the tail.
It has a head, a body, and a tail. Right? We're going to have to account for the head, the body, and the tail. Okay. So let me see. All right, not bad. Okay, relax. So zoom in from here. So it's really have to be working hard for this one here. There is the thalamus. You see my big egg? Yes or no?
Wow.
You see that big egg?
Yes.
Yes. Must fill up the screen here, sir. There, sorry. Right? So whenever the structure, there. Big, isn't this a big thalamus? Then that is the head of the caudate nucleus. Right? And you'll see that if you follow it around, it now goes over the what? The thalamus as the body. So the head is going to become the what? The body. It's going to become the body. And then now it's going to continue into the inferior horn as the tail. And in between, look at this brain here. In between the caudate nucleus and the thalamus, you'll see a band. What is the name of that band? Paul. What is the name of that band that we find between the caudate nucleus and the thalamus?
Stripe.
And that's the stria terminalis. So the main output of the amygdala will be the stria terminalis, okay? And that stria terminalis is going to end primarily in where? Where is that stria terminalis going to end? In this area right here called the septal area. So the stria terminalis is going to end in the septal area. It's the main efferent of the what? The main efferent of the amygdala. The amygdala is also going to have, Dr. Francis will tell you, ventral amygdalofugal fibers. He likes to talk about that. He likes to talk about centripetal forces and centrifugal forces. The fugal forces are the ones going out, right, Lennox? And the petal ones are going inward, right? So sometimes you'll see something, if it's not held on, it will just go on a tangent to the circle, right? So that's centrifugal force, okay? So the amygdala now is going to send out fibers, and those are called the ventral amygdalofugal fibers, and those ventral amygdalofugal fibers go directly to the hypothalamus for an immediate response, okay? If not, you can go on the Knutsford Express and go on the stria terminalis. Knutsford Express will stop in Ocherias, will stop in Falmouth, and then will drop you at the airport in Montego Bay. Right, but you have to do stops. Okay? The stria terminalis is a long fellow. The ventral amygdalofugal fibers is quick. Okay? And what's another output of the amygdala? And what is referred to as the diagonal band of Broca. Right? The diagonal band of Broca. And that's going to travel with thalamus striate vessels. Okay? Right, so we need to do one more very important diagram. Sorry, can you grab a phone, please? I have to take off
Diagonal band of what? As in Broca's area?
Just relax. I need my, before the thing gets wet here. Just relax.
The central area.
Just relax. Just relax. So, I had a colleague, and that colleague was very, very interested in his neuro. Right? Very, very interested in his neuro. Right. And he also went to the same university as?
You?
Right. That was the University of Berlin. Okay? And he went on to the Max Planck Institute, and the Max Planck is one of the top research institutes. And he went to work on the suprachiasmatic nucleus. And he's in Gray's Anatomy. Okay? Many publications, brilliant man, Professor Gardner. So that was my very good friend. All right, so there we see now the thalamus, right? That's the thalamus right here. And there we can see now that's the head of the caudate nucleus. Watch me now, you know. That's the head, and the head will become the what? The body.
Which then becomes.
Just relax. And the body will swing around. Don't like that. He loved this neuron a lot. Okay? When it becomes the tail. So this is the head, then there's the body, and then down here we get the what? The tail. And the tail of the caudate nucleus ends in what? The amygdala. 300 marks. Will end in the amygdala. Right. So we can superimpose on this now the lateral ventricle. So this now is the anterior horn of the lateral ventricle. There it's coming around. That's the posterior horn of the lateral ventricle. And that's the inferior horn of the lateral ventricle. Okay? So you can see now that, and then the inferior horn of the lateral ventricle is floored by what structure here? The hippocampus. Okay? So that structure there is the hippocampus. So the hippocampus is lying in the floor of the, so you can stand. Let's look a little man and put a little man to stand up. Dr. Barnett would do this. Dr. Barnett, see him right? Is he in here? Yes or no?
No. Oh, yes.
Oh,
Is he?
yes, Dr. Barnett. Dr. Barnett is my good friend, you know. We are what are called partners in crime. Right. But we are retired, right? Who says we are retired? Retired. Put us off to pasture. So this is the what? That is the corpus callosum. Okay, so there you can see the corpus callosum. And you can see that I am in the body of the lateral ventricle. And I can straddle two things like that. I'm stretching my legs there, and I'm standing on two things. I'm standing on the thalamus, and I'm standing on the structure which is going over the thalamus, which is the body of the caudate nucleus. Okay? And in between those two, right, with the colors will be running out of me, but in between these two, traveling right in between those two, will be the stria terminalis and the thalamostriate veins. The thalamostriate veins and the stria terminalis. And you know that the thalamus has a layer of white matter on the top of it, and that layer of white matter is known as what? That's the stratum sonalis. No. If this is the hippocampus, I can come off of the hippocampus as a structure which is known as what? So there is the alveus and the hippocampus, and the alveus is going to give rise to the fibria, yes or no? Yes. And the fibria is going to give rise to what? The crura. So when the plane takes off, it is now become the crura of the fornix. And the crura of the fornix will now take off, and then just below the splenium of the corpus callosum, there's what is called the hippocampal commissure, or what is referred to as the lirida davidis. Okay? Give a chance. And the fornix is going to come around, and then swing down, and then come down like that. Okay? So it's going to swing over, and then form the anterior column, and then that is going to be in relation there now to the what? To the anterior commissure. Okay? And just like a curtain, see these curtains here? The fornix now has a little curtain attached to it, and what's the name of that curtain? That comes right around like that. What is that curtain that's going to attach to it?
Is it a
And that curtain is referred to as the septum pellucidum. Right. And we make a space in between that, and that's referred to as the cavum septum pellucidi. We're having fun. That's the anterior column of the fornix. That's the foramen of Monroe. And what did I say the fornix does when it reaches the anterior commissure? What's the word I used? Crystal, what's the word that I use, love? That the anterior commissure will come down to do what? Sorry, the anterior column of the fornix will come down to do what with the anterior commissure? It will straddle it. Right? It does what? It straddles it. The posterior commissural fibers are going to the mammillary body, and the anterior fibers are going to what? The septal area. So that septal area is receiving not only from the amygdala and the stria terminalis and the ventral amygdala, the diagonal band of Broca, but it's also going to receive from the fornix. So amygdala outputs, hippocampal outputs will go to the septal area. Okay? And the septal area, as you know, is going to communicate primarily with the thalamus, through which pathway? Always asked in the exam, and that is the medial forebrain bundle.
Yes.
The medial forebrain bundle. Okay? So if we know this diagram, okay? If we know this diagram, and we're not now.
I did not
No,
steal
it's
it.
here.
It's here.
Then we can start cutting sections and trying to do what? To orientate those sections. So we're going to cut sections going like this. We're going to cut sections going like this. We're going to cut sections going like that. We're going to cut sections going like that. We're going to cut sections going like that. And we're going to cut sections going like that. Okay? So maybe we'll end up with about 1, 2, 3, 4, 5, maybe about 6 sections. Okay? Very good. All right, so relax. Give a chance. So, no, just to tell you, just because I can't draw and cut, okay? Because that's hard. Just to tell you that when we go through the front of the brain, watch here now, we're going to get a section like this. This is A, and we're going to get a section like this, which is B, like that. Okay, and this is the, let's say A first. We're going to see a section like this. This is the anterior limb of the internal capsule. Yeah? Yes or no? Yes? Yes? I don't hear anything.
Yes.
Yeah. It's some different colors. I've used green and orange. So who is going to lie out here? Okay. Who is going to lie here? Okay. Yeah. See, I started. Good. So, who is this boy and who is this boy? Just related to this diagram right here. So medially, this boy is going to be the what? The head of the caudate nucleus. Head, caudate nucleus. Laterally, who is it going to be? Putamen. So you're going to find the section. This looks like a U-shaped magnet. You know, Paul? Like a U-shaped magnet. Let's enjoy ourselves. So out here is the putamen. Here is the head of the caudate nucleus. And anterior and inferior, they're in continuity. And when they're in continuity, that area is called the ventral striatum. Okay? And the nucleus accumbens, which is super important. The nucleus accumbens lives right here. Okay? Right here in this area of the ventral striatum. So out here, that's the putamen, and over here, that is the head of the caudate nucleus. We're going to book up now section B. And in section B, right, and then we ask you all kind of things in the exam, you know. What is in this? Which is this is where it's afferents, where it's efferents, blood supply, all kind of angle. Who's going to set all the bank? Us. Who is us?
You.
You.
Oh.
Yes, partner. Okay, so when we come back here now, who are we going to find out here? Well, out here, we're going to get, look what we're going to get. All of the lentiform nucleus. Reasonable? So out here we're going to get all of the lentiform nucleus, which will be medially globus pallidus, and out here will be putum. Okay? Reasonable? Medially will be globus pallidus, outwardly will be putum. Then we're going to see a new man appear on the scene. Wow. Who is this new man appearing on the scene here? Thalamus, Bogo. And then who are we going to see on top of the thalamus, right here? Who is going to be there? That will be the body of the caudate nucleus. Right. And in this little part right here, who is going to be Jamaican? Say, juk up in this little area right here. Juk up. The stria terminalis and the thalamus striate veins. Thalamus striate veins and the stria terminalis. And we, by the way, we're always going to say fornix. Okay, fornix is always going to be there. Okay, and then this is going to be the what? That's going to be the what? The lateral ventricle. Reasonable? And that lateral ventricle is going to attenuate down into the what? The third ventricle. Isn't that so? And we may see an interthalamic adhesion. No. Early on in our sections, we're going to see the amygdala. Okay? See him right there? We're going to see the amygdala. And the amygdala will be lying right on the cover of who? The uncus. Okay? When we go a little and we don't see the inferior horn of the lateral ventricle. When we're, and by the way, that's parahippocampal gyrus. Isn't that so?
Yes.
So a little later now we're going to see the parahippocampal gyrus. And the parahippocampal gyrus is separated by a very important sulcus. What's that sulcus that separates it lateral? What separates it lateral from the occipital temporal gyri? And there's the fusiform area and all that collateral sulcus. So watch hard now, you know. Parahippocampal gyrus, you following me, yes or no?
Yes.
The parahippocampal gyrus is going to continue on with somebody called what? What is that area called? What is that area called?
The thing.
I don't hear any answers. Paul, what is that area called? Which is now going to continue as the hippocampus here.
Oh, I wasn't going to say that.
What is that area called? Right there. What is that area called? So that's the parahippocampal gyrus. Trace around, and it's going to, this area connects us now to the hippocampus. What is that area called? Paul. David is getting very disappointed. Very disappointed. And next thing, she selects me instead of you. Reasonable? You're waiting for the answer. You have to give me the answer. Tough luck. Parahippocampal gyrus, transitional area, hippocampus. So I don't hear answers from you. In the roof of the inferior horn, we're going to find the tail of the caudate nucleus and the what? The stria terminalis and the thalamus striate veins. Okay, so we're going to be looking for all these things in our journey. Give a chance.
He's waiting. He's waiting. I don't think so.
Wait a minute. Some gloves. Oh, it's like I've run out of gloves here. This is not a good story. Let me get some gloves over there. Give a chance. All my gloves are formally.
So he said, why he put them those areas on the hippocampus. Bro, I've never heard of this in my life, bro. No, I was never gonna get this one. The subiculum. No. He said it yesterday. Somebody said it one time.
Oh, I'm waiting on you.
Somebody says it's a subiculum.
300 marks.
The what?
Subiculum.
Who said that?
It wasn't.
He bailed himself out. He didn't want to lose Davion.
Okay, that's fine.
Valentine's coming up.
Let's give us an answer.
Valentine's. Wait,
He's getting good.
Let's go for gold.
just go.
Wait, what's the number?
Let's go for gold, MG.
You have to bring it back,
I'm
man.
not here, bro.
So who's here now? Grade 9. Okay, so we're going to
Brain what?
Brain night.
Grade 9. Yes.
Wait.
Right.
He's gonna do it in front of us?
300 here.
And this is this, bro.
Straight through.
If I do, you have to do the name.
Excellent. 300 marks. 300 marks. Why I say 300 marks? Sometimes it's not 300 marks.
Why?
Sometimes a dead story. What is this that I've gone through? What is that we've gone through right here?
That wouldn't be bad yet.
This is the genuine of the corpus callosum. That's the genuine of the corpus callosum, right? Yes or no? Yes. And then we see this bulge right here. See this big bulge right here? You see it right there? So that's bulging. See? Look at that. 2 big bulges in there. And those 2 big bulges are what? The head of the caudate nucleus. Okay? So we're looking at the head of the caudate nucleus. So that's the head of the caudate nucleus right here. Yeah? And that there is the what? The genuine of the right. No. There's a lot of stuff going on here. Okay, and there's a lot of stuff going on here. Okay, so these are areas of the corona radiata.
Okay.
Okay, so in the brain we have fibers running this way,
And that way.
we have fibers running that way, and we have fibers running this way. 3 different axes. So when we look at the connectome, we have to consider the fibers running in all different directions. For example, I might say to you in the exam and put a pointer right here and ask you what major association tract occurs here. Okay? Can anybody answer me? What's the major association tract that connects it? That's located right here.
Down on that vertical.
So, remember, relax yourself. Just relax. If we put back on the surface here,
I agree with her. Superior.
yeah, the superior longitudinal fasciculus. So my dear, camera, if we can come off on it. Yeah, so along here, that's going to be the superior longitudinal fasciculus, connecting all of that area and connecting all of these areas coming right into the prefrontal cortex areas. Along here, that will be the inferior longitudinal fasciculus. And then the most important boy, and a lot of research, is a man who's coming around like this. And he's just hugging and going all around the insula. So he's providing fibers to going into the insula. And he's just hugging and coming right around like that. And that boy is the most, a very, very important boy. So, and that's referred to as an arcuate fasciculus. Okay? So we have a superior longitudinal fasciculus, an inferior longitudinal fasciculus, a hell of a big boy coming all the way around here and splaying himself out, called the arcuate fasciculus. And down there, deep down there, is a little boy called the uncinate fasciculus. Okay? So when we look here, this is very much the area of the what? The superior longitudinal fasciculum, sending input into the what? Into the prefrontal cortex, and connecting up all the way from the visual cortex, association visual cortex, going through the parietal lobe, going right through, and finally ending us here. Okay? Then around right here, you're going to be getting fibers that are coming from where? From the corpus callosum, right? And from the internal capsule. Okay? And the fibers are coming from the internal capsule. Very important. Those fibers are the ones that are connecting you into this. And this, look at how this is all crumpled up. You see how this is, look at the difference in here to here. So this is the prefrontal cortex. Okay? So all of this thinking we're doing, and Crystal is there looking at the screen and making decisions and all of that, and all of that. All of that is occurring here. She's processing all of that information here in the prefrontal cortex. Okay? So all of that is coming now from the dorsomedial nucleus of the thalamus and the anterior nucleus. Relax. So you can see now, very interesting, is that is the head of the caudate nucleus. Next section. Okay. Now, 3, very, very good. Okay, we're just starting to see it, but still, we're in the land. Wow, look at this. This is magical. This is rare to see, you know. Lennox, look at this, my friend. I, Michael Gardner, have not encountered this maybe in all my years of anatomy. Yeah, never have encountered this in all my years of anatomy. So good. And what do you think that is? Right, that's the cavum septum pellucidum. Yeah, so that's the septum pellucidum. And I promise you, I have never, and I've been in anatomy for how many years with Livia?
30.
45.
He's youthful.
So this year marks how many years?
He's the same.
45 years in anatomy.
He teaches so many.
And for Dr. Ledenque, how many years in anatomy?
40.
Take a guess.
16.
20.
20.
So this year is 20 years for Dr. Ledenque. And how many years for Gardner? 45. But I'm much younger than him.
Very good.
Youthful,
So
youthful.
there, this is a fantabulous section of the cavum septum pellucidum. Never have I seen this so beautiful. Okay? Right. Notice now that we have, so the next section, I mean, let's relax this a little. Next section. Wow. The cavum septum pellucidum is massive there. Okay? No. No. There we are seeing section A. Where is A though? A. This is A. Just hold it up like that on the screen like that. Okay. So my dear, if you can focus on this diagram. Right here. Yeah. So there you can see that's the internal capsule. This is the anterior limb of the internal capsule. That's the head of the caudate nucleus. That's the putamen. And that area is the ventral striatum. Just focus on that. And see it right here. See the anterior limb of the internal capsule. You see Davia, yes or no?
Yes, yes I do.
Right? And the reason why it's called a striatum is that it has this kind of striate appearance. So that is the putamen, and that's the head of the caudate nucleus.
Oh, sorry.
And this big area right here is beautiful. Look at the cavum septum pellucidum still. And there you can see, that area is the ventral striatum. Ask the Derek, can you just focus fully on this? It must fill up the screen. That's Max. Okay, wait, sometimes the angle. Very good, okay? Yeah, just that angle. So there you can see, you can put him down now. So that's the anterior limb of the internal capsule, that's the putamen. Look carefully, that's the external capsule. You see it, yes or no?
Yes.
That is the claustrum,
That's the clearest I've ever seen.
and that is the extreme capsule. See the extreme capsule there? and that's the insula.
Insula.
So maybe this is like the anterior short gyrus.
Anterior shoulder.
So remember that's the part involved with
Empathy.
empathy,
Pain.
pain,
Anxiety.
grief,
Distress.
disgust.
Yeah.
All of those areas are with that, okay? All of those areas are there with the anterior insula. And remember the anterior insula is operating just like a mini cerebrum, and it is integrating in a posterior anterior direction. Anterior part is limbic. So that's the claustrum, and that is the extreme capsule, and that's the insula right here. Okay? And here we're now seeing the corpus callosum, and I will say that this person has a very small corpus callosum. This person's corpus callosum, the corpus callosum, is developed to varying degrees. Then we see this boy, which is right here. Okay, so what gyrus is right here? Who is that gyrus? So that's a singular gyrus. Dave, you look over my shoulder here, sweetheart. And who is that right here? Who is this right here? And that is cingulum.
Yeah.
Okay, you can
makes
see the
sense.
cingulum right here. Okay, and who is occupying this big boy right here in an anterior posterior direction? Who is the association fiber who is overwhelmingly taking up this area? And that is the superior longitudinal fasciculus. Right. And then we can see now, if we trace the anterior limb of the internal capsule, we see that it is coming up into this also, this white mass. So these projection fibers here also form the what? The corona radiata. Okay. All right. I've not reached the uncus yet. Okay. When I go through the uncus, I'm getting close to the uncus. So, yeah, Gogo. All right. Yes. Right.
Yeah, why I got so well.
So here,
It's a brain knife, bro.
I'm not got into the amygdala here yet. Okay? But there we see the one. Who is this here, Davio? Come identify now, Davio. Who is that?
Is that not still there?
This sweetheart, but what part?
Without the anterior.
This is still the anterior limb. Look at, hold this diagram up. How many gray masses you see on the medial part? One. Then you're going to see how many gray masses on the medial part? Two. Right? So if you just see one in the exam crystal,
It's anterior.
then you know that's the head of the caudate nucleus. Because you're going to have the detractors, head, body, tail, all of these kind of things. Okay? So that's the head of the caudate nucleus. That's the anterior limb. So that anterior limb is going to convey primarily fibers from the dorsomedial nucleus to the prefrontal cortex, and it's going to carry fibers from the anterior nucleus, thalamocortical fibers from the anterior nucleus to the cingulate gyrus,
To the
part of the
cingulate.
circle of Papez.
Yes.
Davia, who is this, my dear? Davia, who is this?
Okay, I look like one.
I'm not asking Paul any questions here.
Oh, you need to ask
No.
Paul.
Who is this?
Yeah, I'm getting sure.
Paul is proving to be disappointing.
No, I'm being disappointed right now, so
You're
I
just
can't
having
hate
fun
too
here, Paul.
much.
So this is the anterior
Anterior
commercial.
commercial.
Good job, Dana.
Yes, and you can see where he wants to go. Where does he want to go? To the temporal lobe. Remember? He wants to go to the temporal lobe. So that's the head of the caudate nucleus. Alright, and you're seeing a bit of the globus pallidus and a bit of the putamen. The external capsule is very, very prominent. Those are going to carry some corticostriate fibers, right? The claustrum is here, and the extreme capsule is not so great. Alright. Okay, wow, look at this here now.
Anterior commercial.
Right. Okay. So we're just on the edge of the amygdala. In fact, I would say that's the anterior end of the amygdala. Okay, that's the anterior end of the amygdala. And look right in here, Davio. Is it on the screen, yes or no, Davio?
Yes.
Well, if you tilt it.
Yeah, is it on the screen, yes or no?
Yes.
Yeah, but
What am I showing? Look down and tell me, what am I indicating? This is stria terminalis.
I can see it.
It's hard for them to see. Boy, the way I'd have to tilt it, but that's a stria terminalis. You see this, yes or no?
Yes.
Very, very big in this brain. And there we can see that that is the what? The head of the caudate nucleus, right? You can now see the division between the globus pallidus and the putamen, the external capsule, the claustron, and the extreme capsule. And this guy has a very nice little insular right here. Okay? Look at the cavum septum pellucidum. This is very, very interesting. It's very, very interesting. Honestly, I've never seen it of this size. Okay?
The what?
Never. 0.00 I've ever seen that. So, right.
Another slide.
So I'm going to go right through
So it's it.
Dr. Barnett's special area.
Which is?
See Dr. Barnett right there? Very good.
Sometimes they can fix for a while.
Barnett and my good friend. Our offices are very close to each other. You have Dr. Barnett's office, then Dr. Thomas,
Yeah.
and then I'm at the end. He says you go further down, they get more crazy. So I'm right at the very end. So I'm max out.
I feel like Thomas is
Good job. Dr. Thomas is right beside me. Barnett is not too far away. Oh, beautiful. Fantastic. But this one, wow, this is a bit of an anomaly, you know. A little bit of a strange guy. Because here, why this is a strange guy. Usually when you see the amygdala, you're not seeing the inferior horn of the lateral ventricle. But the inferior horn of the lateral ventricle is just coming like that. See how it's ending? You see how it's ending? Like that in the amygdala.
You just got it perfect.
Okay? We won't think here. However,
however, comma.
that is the collateral sulcus, and sometimes, which I will show you when we do the limbic system, it will give rise to a parallel void to the hippocampus known as the collateral eminence. Okay? Not in all brains, this is the collateral eminence. This is a big boy here, and that's the amygdala. So see the amygdala there? He's involved in the cat. Electrically stimulate that, the cat starts to raise all its hairs, lurch up its back, the claws come out, and the cat starts to hiss. Okay? In the worst of murderers in America that are locked up in cells all by their own, they have done PET scans on them, and they have very large amygdalas.
Yikes.
So the amygdala
This
is
person was
involved
a
with
questioner.
ferocious behavior.
This person was a little
Defense and attack, but it is there to protect you. So if you see anything that is a threat to you, you immediately, even the expression on somebody, when you look at the expression on somebody, right, can be a nice expression or can be a menacing expression.
menacing.
Right?
Menacing.
And that's going to activate the amygdala, which is going to activate the hypothalamus, which is going to activate the sympathetic system. So that's the amygdala right here. And that amygdala has watch here, a ventrolateral part and a dorsomedial part. The dorsomedial part of the amygdala is for smell, olfaction, and will receive the lateral olfactory striae. So if you go in the exam and the pin is right here, and you see some things, what is going there? That's the lateral olfactory striae. On this side, that is the ventrolateral part. Out here, that's the parahippocampal gyrus. No. The question is to a lady by the name of Devium. My God, look what you think I'm seeing here still. Look how this, the cavum septum pellucidum is so massive. Anyway, who lies right here? So Devium, who is that though? No man, this big grey boy right here. Who is this big grey fella here?
Is it the body or?
That's the body of the caudate nucleus.
Yeah.
See, now I'm seeing two grey masses. See there? See there, Hugh Barnett? Two grey masses. So therefore, this is the posterior limb of the internal capsule. So this is the thalamus. For the first time you see the thalamus, and that boy is the body of the caudate nucleus. That's the amygdala. Now if you look at this here, you can see, look at this massive structure here. You see that massive structure here? That's the globus pallidus. And we can see that it has an internal part and an external part. And there we can see the putamen, the external capsule, claustrum, extreme capsule. Okay? So right in that little area right here. Okay, let us go down. This is third ventricle right here. See third ventricle? So the third ventricle is very large. Just relax. So you have to wet it before the green light, you have to wet it. Give a chance.
I'm eating all the slices.
Okay. Right. Okay. Right. So Paul, are you with me? Yes or no?
Yes.
Okay. So if Paul can get this, I give him gold.
You mean I can give
Who
it
is this structure right here? Who is that structure right here? So right now we're at the back of the interpeduncular fossa. See it here? Watch here, watch. That's the thalamus right here. You see the thalamus? We have just gone through the mammillary. We're at the back end of the mammillary bodies. Right? And from the mammillary bodies we find this white bundle springing up into the air. And that's something Dr. Lenegui likes a lot. That's the mammillothalamic tract of Victor-Hazard. Okay? This is the mammillothalamic tract of Victor-Hazard right here. Okay, the mammillothalamic tract of Victor-Hazard. There you can see the basilar artery. See the basilar artery here? And you can see its penultimate branch. What is the penultimate branch? The superior cerebellum. And we have cut through the posterior cerebrum. So we're at the back end of the interpeduncular fossa. So the third nerve, we dissected through the third nerve. Okay? So that big boy, the whole of this big boy is the thalamus. Look how massive the thalamus is. You see how big he is? You see how big the thalamus is? And then who is this man right up here? And that's the body of the caudate nucleus. Okay? Right here now, that is the hippocampus. See the hippocampus right here? Yes or no?
Yes, I can see.
Yes. And then in the roof of the inferior horn of the lateral ventricle, who do you think this gray mass is right here? In the roof of the inferior horn. And that, if you see it there, that's the tail of the caudate nucleus. The tail of the caudate nucleus is in the roof. The body is in the floor. Okay, so that's the body, and this is the tail. And this man here is the hippocampus. And we always ask you in the exam, blood supply to the hippocampus. And that's by the anterior choroidal artery. So there you can see now the posterior limb of the internal capsule. And there we see now the corona radiata. Now the next section I'm going to take, I'm going to go at an angle. Okay? When you reach back to this level in the brain, okay, so we can see all our little boys here, I'm going to go at an angle. Okay, I'm going to tilt at an angle of about 30 degrees. Like that. Excellent.
So we're going to cut until I'm
Very good. And I hit on magic.
magic.
Yeah, hit on magic. So, by the way, so this cadaver where we got this man here, this man has a bit of what? He has a bit of communicating, sorry, non-communicating hydrocephalus. His ventricles are quite enlarged. Okay, these ventricles, that ventricle is quite enlarged. Okay?
Non-communicating.
Now you ask me why. Whoa, look at this, my friend. Look at that boy. Who is this boy right here? Look how big he is. Sylvia, come on, Daniel, come on, look right here, look. Forget about Paul and Rebecca. Who is that right there? Look how big that is. That's the great cerebral vein of Galen. That's the great cerebral vein of Galen. Definitely this patient has a hydrocephalus. Okay? And that's the great cerebral vein of Galen. Now I give Davio, I'm offering you now diamond. What am I offering you?
Not going to get any
Diamond.
I'm so sorry.
If you can identify that structure.
I can understand.
Yeah, wait, let me see if these folks now. Wait, they can now see beautifully.
It looks like a
So
butterfly.
what, as I said, is very interesting is the cavum septum pellucidum. It's very large. You see the cavum septum pellucidum, yes or no? Yeah, see the big space, right? And who do you see right below it? The great cerebral vein of Galen. So this section is a section through the what? Midbrain. So we've gone right through the midbrain, right? And the specimen that I was searching and searching to show you for in the brainstem, I looked through all my things and I couldn't find it. And now I've got it, and there it is. So who is this structure right here? See the structure right there, David? Big white structure. Rectangular in shape or trapezoid in shape.
That's what it's called, the trapezoid body.
Who is that boy right here?
Is that not done?
Right.
I think that's answer.
Okay?
Is the trapezoid
So maybe I'm offering you diamonds, you know.
Which so sorry.
No, you can't. Don't disappoint me, though. Don't disappoint me.
Is it the
Don't disappoint me. Who is that structure? Crystal, who is this structure?
I'm running on no sleep right
Because
now.
if you're in the period, it's going to be grey and then you have white matter.
Okay, Paul, we have to revert to Paul, unfortunately. Paul, who is this? I'm just joking with you, you know. Paul, who is this? Because I have the greatest respect for Paul. Sometimes with people, I think when the night time we're talking, you know.
in the night?
And yes, we're good friends, right? We're talking.
We talk about
And who
Paul
is it?
at
We
night.
say we're always commending how Paul is very good.
Yes, he is.
Very good. And Davey and some of you, and we always say, we're interested in you guys, you know. Yeah, we're interested in you guys. Okay?
Is
So,
it the
who is this
trapezoid?
structure? Who is this island which is right here?
I feel like the words are clues, but I don't know.
And that is the decussation of the superior cerebral peduncle.
At the
It's
level
in
of
where
the
John
trapezoid
And the
right now.
superior cerebral peduncle.
At the inferior.
So therefore, that is going to tell us now what? That this is the inferior colliculi. That's the inferior colliculi. That's the aqueduct of Sylvius.
Yeah.
That's the periaqueductal grade. So if I were to ask which cranial nerve